Hi everyone, it's Miss Kilroy here. Today we are going to be doing what's called flipping the classroom, and that means instead of taking notes on the new content in class, you're going to be doing that right now so that we can get to the fun stuff tomorrow and get started right away on a lab. So here's what I need you to do. Get out your science notebook and turn to page 43. This is going to be the start of our new unit. It's called density, so I want you to write density across the entire page, telling us that this is a new unit on page 43. If for some reason your page numbers are messed up and that's not correct, you have something on page 43, turn to the next blank page and title that page 43. This way you'll be on the same page numbers as everyone else and start doing the same thing. Okay, so let's get started with our notes. I'm going to click on our notes and we're going to view our slideshow. So you wrote density really big on page 43. Now I need you to turn the page, leave page 44 blank, and then on page 45 write do now at the top. So make sure you include a date section, 3 fingers from the left, and we're just setting up our notebook for the next unit. On page 46, leave it blank. We will get back to that page next week. Page 47, write introduction to density at the top. So make sure you're setting up all your pages C-note style, which means 3 fingers from the left, you have a notes/question section, 3 fingers from the bottom, you have a summary section. Now, if you ever get lost, you can pause this video, rewind it, go back, rewatch it. This way, the timing's up to you. Also, if you check on EDU, go to resources on the left-hand side, click on notebook. There are pictures of all the pages, so what they're supposed to be looking like. So page 47 will end up looking like this with notes. So right now you just have the C-note style set up. You wrote introduction to density at the top, so now let's get started on the information. Okay, we have all of this stuff. Remember, you can go back and rewind if you missed it. So density, our definition of density is the amount of matter in a given space. And the formula for density is mass divided by volume. Our units for density is going to be grams divided by cubic centimeters because we measure mass in grams and volume in cubic centimeters. So we're just taking those units and dividing them. You can also write grams over milliliters if we have a liquid volume. So here's my example. All of these boxes have the exact same volume, but if you notice, the amount of mass or matter in a given space changes. So this is the least dense because there's the least amount of matter in here. It gets more and more dense as you go down because there gets more and more mass or more particles. So make sure you write down all of this, everything here, even these 3 boxes. Okay, when you're ready, here's the next portion. Stay on page 47, please. You should be able to fit the next part on page 47. So here's another example. This is the size of atoms in a given space. So if you notice, hydrogen has a mass of 1 AMU. So given the same space, the same volume, there's only 1 atom per this given space. Compare it to oxygen. Oxygen has a mass of 16 AMUs. That means 16 particles in this given space. So oxygen is more dense than hydrogen. In density, you are always comparing 2 things. So you don't just say something, oh, metal's dense. In comparison to what? Okay, you're always comparing things. So in our hydrogen and oxygen example, oxygen is more dense, so it would sink to the bottom in comparison to hydrogen, which would float on top. So if you had these 2 gases in the same space, oxygen would sink to the bottom and hydrogen would float on the top. Things that are less dense go on the top, and things that are more dense sink to the bottom. Okay, make sure you wrote down all of this on page 47. Okay, turn to page 49. Write density continued at the top, and I want you to continue on with the notes. So you make sure you write Roman numeral 2, and then you start writing this down. So like what I was saying before, objects that are more dense will sink. And when you put things in water, it depends on their density if they're going to sink or float. So water has a density of 1 gram per cubic centimeters. So this is a 1 centimeter by 1 centimeter by 1 centimeter block, which means it has a total volume of 1 times 1 times 1 for 1 cubic centimeter. So if this was filled with water, it would have a mass of 1 gram. Doesn't that work out nicely? 1 cubic centimeter of volume of water is 1 gram. So our density is 1 gram over cubic centimeters. Here's just a silly example, a picture I took from China, the water cube, where all the water Olympic sports took place in the Olympics in the past. Okay, make sure you wrote all this down, including the diagram. Next part, you should still stay on page 49 and write Roman numeral 3, calculating density. So we're going to use a specific way of calculating density, and you need these 3 tools right here, right? So our formula for density is mass divided by the volume. So to calculate the mass, we have to use a triple beam balance. To find the volume, we can either use a ruler to measure the sides of a block, or if we're finding the density of a liquid, we can use the graduated cylinder to find the volume of the liquid. So just a definition of our terms, M stands for mass, and like I said, we use the triple beam balance. The units are in grams. V stands for volume, and like I was saying before, we use a graduated cylinder or a ruler to measure the length, width times height of the object in order to find its volume. Okay, so these are simple calculations to do, and our units are going to be the same. We're going to have milliliters for our volume or cubic centimeters for our solid objects. Okay, now you can turn to page 51, and this is density continued. So this is our second part of calculating density, and like I said, we're going to solve these problems in a specific 4-step method. Every time you see a density problem, it's going to look kind of like a word problem, and you have to follow these steps in order to calculate it properly. The first step, you need to identify the given information. So they're going to throw out all this information. You have to identify what goes with what. What is the mass? What is the volume? What are they looking for? What should we find? Step 2, you need to write out the formula. For density, we're always going to write D equals M divided by V. Step 3, you plug in the numbers into the formula. A lot of people get confused here and mix up their numbers. Where it says M, you have to fill in your numbers that you got for mass. Step 4, you write the answer with the units. Density, the units are always going to be grams over cubic centimeters or grams over milliliters. Now, on your test, every density problem will be worth 5 points. You get 1 point for identifying the information, 1 point for writing down the formula, 1 point for plugging in numbers correctly, and 2 points for writing the answer. So 1 point for the correct answer, 1 point for the correct units. Okay, continuing on page 51. Here's an example, right? See example. And you need to write down this whole example. So here it is. A sample of metal has a mass of 400 grams and a volume of 200 cubic centimeters. Calculate the density. So we start, we start by identifying what we know. So we know the mass. So underline mass of 400 grams. Next part, you need to circle the volume. Our volume is 200 cubic centimeters. So first step, we just write down what we know. M equals 400 grams, V equals 200 cubic centimeters. Step 2, write down the formula. Density equals mass over volume. Step 3, you just plug in those numbers. So my mass, my 400 grams gets plugged in for the M, and my V, volume, my 200 grams gets plugged in for the V. Okay, then we just use a calculator and we can solve the problem. These numbers are simple, so we can do it in our head, and you can find out that our density is 2.00 grams over cubic centimeters. Now, if you want to know if this floats or sinks in water, you just compare it to the density of water. Now, the density of water is 1 gram over cubic centimeters, and this example of density, this metal, has a density of 2 grams over cubic centimeters. So because this is more than 1, it's going to sink in water. Now, if you had an object with a density less than 1, it would float in water. Okay, so that is the end for our lesson today. You need to make sure you have all of these notes written correctly in your notebook. The notes for density should start on page 47 and end on page 51. Now, if I go back, if you thought I went a little fast, I want you to go back to that resource section. Let me take you guys back to your home page. Here's your science homepage. Go to resources, click on your notebook, and all these are examples. So like I said, we started on page 47. That's what you need to have on page 47. I'm going to scroll down to page 49 and page 51. Okay, so if you missed anything, pause the video, rewind it, rewrite it down, or you can go back to EDU. Okay, so good job today. Good job taking notes, and we will get to the lab tomorrow. Good job.